Here's a problem interpreting an object's motion by looking at a position versus time graph. The first thing I like to do is mark these off where you see some changes. When that slope starts to change, either getting greater or less than, mark those off on the graph so you can get things lined up in the right spot. And remember that on a position versus time graph, the velocity equals the slope, which means that the slope equals the velocity. So what we can do is we can find the slope of that first section, which is rise over run, is about 1.5. So we draw our line in there at 1.5 meters per second. The slope on this next stretch is positive, but it goes to 0. So our slope goes to 0, our velocity goes to 0, and then on the next stretch there, the slope is 0, so the velocity is 0. Then I'm going to go to this last section first before we do the middle part there. And the slope on this rise over run, it's a fall, so it's negative, and we get negative 1.4 meters per second, so I put that in on my graph. And then I look at that spot that I skipped. The slope goes from 0 to negative 1.4, so I draw in my line starting at 0 and going down to that negative 1.4. For part B, it wants to know the velocity of the elevator at 8 seconds. Remember, for a velocity at an instant in time is the slope of the tangent line, and we already calculated that earlier, and that's the 1.5 meters per second. Part C wants to know the average velocity. Remember, that's the displacement over the time, delta x over delta t. Delta is always final minus initial, and that should be x final minus x initial in the numerator. My denominator, my time is from 8 to 24 seconds, so my final time 24 minus my initial 8. Then I look at that 24 seconds and my position as at 4. And again, remember that should be x final minus x initial in the numerator. And my initial position at 8 seconds is 12. So I have 4 minus 12. So I can calculate that my average velocity during that time is negative 0.5 meters per second. Then D wants the average acceleration, which is delta V over delta T, which this time it's V final minus V0 over T final minus T0. My final time is 24 seconds. My initial time is 8 seconds. At the 24 seconds, I can look at the graph and see that I'm at negative 1.4 meters per second. And at 8 seconds, I can look at the graph and I can see that my time, or my velocity, is 1.5 meters per second. I do the subtraction and I get negative 2.9 over 16, which is negative 0.18 meters per second squared.